7.1, connecting intercepts and zeros. So we're going to continue our work in quadratics and dive a little bit more into quadratics in standard form that we started in 6.3. So our essential question is, how can you use a graph of a quadratic function to solve its related quadratic equation? Graphing quadratic functions in standard form, we did a little of this in 6.3. So continuing with this idea. So find the axis of symmetry. Remember, our axis symmetry is x equals negative b over 2a. So I get x equals negative b, which is a negative 4, all over 2a, which a is 1. Two negatives make a positive, and I get 4 over 2, which is just 2. Now to find the vertex, I go ahead and substitute that value in. So I get y equals 2 squared minus 4 times 2 minus 5. 2 squared is 4. Negative 4 times 2 is a negative 8 minus 5. 4 minus 8 is a negative 4 minus 5 is negative 9. So then we would say our vertex is 2, negative 9. So then we want to sketch our graph. So I'm going to plot 2, negative 9, which is all the way down here. And then since our a equals 1, we know we open up because it's positive, and our stretch factor is 1, so it's normal. And so we get a graph that looks like that. Now, to find our y-intercept, what we want to do is we want to substitute 0 in for x. And so I get y equals 0x squared minus 4 times 0 plus 5. All the zeros cancel out, and you get y equals 5. So then our y-intercept is 0, 5. Then our domain is all possible x values. So again, we are from negative infinity to positive infinity, since there's no restrictions on that. And then our range goes from negative 9 to positive infinity. Remember, you can also write this as negative infinity less than x less than positive infinity, and then y is greater than or equal to negative 9. In this case, since our parabola is concave up, we then have a minimum at y equals negative 9. So if you notice, looking at this again, our minimum value, our range value, all happens to be the same as our y value of our vertex. So it's super important to identify that properly. A zero of a function is an x value that makes the function 0. And then the zeros of a function are the x-intercepts of the graph. And then a quadratic function may have one, 2, or 0 zeros. Okay, so looking at our graph here, we want to solve by graphing. And so what I'm going to do here is I'm going to solve by adding 3 over. And that way we get 2x squared minus 2, and that equals 0. But what we're going to do is we're going to put y there. So that way it looks like our equation. So then we go to graph this and we get 2x squared minus 2. And then we graph that. And now what we're looking for to solve is when our y is 0. So 2x squared minus 2 equals 0. Well, when is y 0? We come over here and we look. We get -1 and 1. So then we would say our solution, x equals -1 and 1. Same deal, I'm going to add x squared. And that gives us x squared plus 6x plus 8 equals y. So we'll come over here and we get x squared plus 6x plus 8. And then we can see our zeros there. Our x-intercepts are at -4, 0 and -2, 0. So our solutions to this is going to be x equals -4 and -2. So just another way that you can solve. Given the graph, we know we're just looking for our x-intercepts for our solutions. All right, so let's work through on graphing this whole thing. First thing on this one here, what I want to do is add 17. So then we get essentially y equals x squared plus 8x plus 12. And then find our axis symmetry. So x equals -b, so negative, and then our b is 8 all over 2a, and our a is 1. 8 over 2 is the -4. And then to find our vertex, we substitute that value in, so we get y equals -4 squared plus 8 times -4 plus 12. Simplify, that gives us 16 minus 32 plus 12. And then when you add that all together, we have a vertex of -4. And then when you add that together, 16 minus 32 is a -16, plus 12 is a -4 as well. So we're going to plot that, and we get -4, -4. And then in this case, our a is 1, so it's positive. And since it is just 1, it is a normal. And so we go ahead and get our sketch of our graph. Looks something like that. So now let's find our y-intercepts. So remember, we're going to do that by substituting 0 in for x. So we get y equals 0 squared plus 8 times 0 plus 12. So then we get y equals 12. So our y-intercept is at 0, 12. And then find our x-intercepts, or our zeros. What we want to do is we're going to substitute 0 in for y. And then you get x squared plus 8x plus 12. Now there's a couple ways you can find this. The easiest is algebraically, because graphing it, unless you're using Desmos, is a little hard to get it specifically. So on this one, we can Xbox this. And what multiplies to 12 and adds to 8? That is 6 and 2. So then we get x plus 6 and x plus 2. Which, when we solve, you get x plus 6 equals 0 and x plus 2 equals 0. subtract, and x equals -6, subtract, and x equals -2. So then our x-intercepts are going to be -6, 0, and -2, 0. And let's talk about our domain and range. So our domain is our x values, and we go from -infinity to +infinity. You can do inequality as well, but I kind of prefer our interval notation. And then our range, we go from -4, and we need to include it. That's why I have the bracket instead of parentheses. And then we go all the way to +infinity on this one as well. And since our parabola is opened up, we have a minimum at y equals -4, which comes from our y-coordinate of our vertex. Okay, so let's look at one more here. So axis of symmetry, x equals -b. So we have -3 over 2a, which is 1. So we get -3/2 for our axis of symmetry. So our vertex, we want to substitute that in. So you get -3/2 squared plus 3 times -3/2. So it gives us 9/4 minus 9/2. And then we want to add, so we have to have common denominator, which is 4. So we'll multiply the second one by 2/2. And that gives us 9/4 minus 18/4. So then our vertex is going to be -3/2. And then 9 minus 18 is a -9/4. So as we go to sketch that, we have a equals 1. Plot our vertex, that's -3/2, which is -1.5. And the -9/4 is a -2.5. So we're right in here. And our sketch looks something like that. Our y-intercept, so substitute 0 in for x. You get y equals 0 squared plus 3 times 0. So y equals 0. So then our y-intercept is going to be at 0, 0. Our x-intercepts, we go 0 for y. We get x squared plus 3x. First rule of factoring is GCF, and I can factor out an x. So I get x times x plus 3. And that gives me x equals 0 and x plus 3 equals 0. And subtracting, you get x equals -3. So our x-intercepts are at 0, 0, and -3, 0. Then our domain, do inequality notation this time. So we go -infinity is less than x, which is less than +infinity, and our range is y is greater than or equal to -9/4. And then we have a minimum at y equals -9/4. So a little reflection here. How would the graph of a quadratic equation look if the equation has 1, 0? So once you think of that, come up with an example and we'll discuss this in class. Then you have your quizzes to work on. And our essential question that we will follow up in class is, how can you use a graph of a quadratic function to solve its related quadratic equation? And then your assignment is a worksheet that I'll have for you in class.